In this tutorial, we shall discuss the relationship between electric field intensity and electric potential. It's Kisembo Academy, and thanks for tuning in. Let's consider a charge Q. If a charge Q has been moved from point A to point B within an electric field with an intensity E, it would mean that there is a potential difference between A to B, and there is some work that has been done in moving that charge from point A to B. Now, supposing this charge has been moved through a small distance, let's call that distance dx. It means that the work done in moving that charge from A to B through that small distance is going to be equal to force times that small change in distance. Now, for us to substitute for the value of F, the force, it will follow. We'll get it from the formula for intensity. Remember, we said that intensity is the force per unit charge in the field. So it follows that from the definition of electric field intensity, intensity E is the force per unit charge. And so if we are to make F the subject of the formula, it would mean that F is going to be E times Q. And we said that that negative is going to be as a result, because the charge that is being moved, it is working against the repulsive forces, the other 2-point charges. So it means that we substitute this value of F in that point. And so it means that our new value of work, hence the work is going to be E times Q, which is that, times the small change in distance. And that will be our first relation, or our first equation. So now we have another expression for work, which is work is Q times V. If the potential difference between A and B is dV, where B is at a higher potential than A, then in terms of potential difference, it means that work done is going to be the charge of that, the charge times the change in potential difference, and that is going to be our second expression. So what we do, we equate these two expressions. Work done here is equal to that. The work done in terms of potential difference is that. So it means that it is this expression is equal to that expression, and that is what has been done down here. The work is going to be equal to the work. So the expression, the first expression, equation 1, is going to be equal to the second expression. And if you divide both sides here by Q times dx, Q and dx, this dies with that, and then this goes with that. You remain with our intensity as being equal to change in V over change in X, change in potential difference over change in the distance. So this is the relationship that exists between electric field intensity and potential difference. So to note, NB, dV dx is the rate of change of PD with the distance in the electric field, which is also the potential gradient at that point. So where does this leave us? It gives us an expression that in uniform fields, therefore, intensity is going to be equal to the potential difference with the potential difference, divide that by the distance. This brings us to the end of this video. Simply subscribe to this channel for more, and for the benefit of your colleagues that would like to watch this tutorial, simply share this video. Otherwise, I'll catch you in our next video. For Kisembo Academy, this is Arnold Ranga Kuramya.